Hi class, this video is on, let's see, example 1 of 7.3, and we are going to continue with E and F, okay? So before I start example E and continuation to F, let me give you a joke, because I know a lot of you have been complaining about there were no jokes at all the last couple videos. So here we go. Let's see, what can I think of? Why do bananas have to put on sunscreen before they go to the beach? So why do bananas put on sunscreen before they go to the beach? Because they might peel. Get it? Haha, banana peel? All right. Hopefully you enjoy that toddler joke. So we're solving, so keep in mind that this is a regular. So if you check if this is regular trig function. So technically there is no restriction, but remind ourselves of where they want our answer to be. So they wanted our answer for theta to be from 0 to 2 pi, inclusive at 0. So inclusive at 0, but not inclusive at 2 pi. Okay, so the best thing to do is to see if we can change anything. Okay, we have sine square here, a regular sign here, and a cosine. So in one equation, that's a lot of different trig functions. So what you want to do is, hey, can I change one of the trig functions into common trig functions? So for example, cosine square seems to be a little bit odd in this equation. So the first thing I'm going to remind you of is this Pythagorean theorem for trig. Cosine square of theta plus sine square of theta equals 1. Super important that you know this. Okay, we learned that already, but we haven't used it, so hopefully this is coming back. And I want to get rid of cosine square and change it to sine square of something, so I can combine like terms. So I'm going to solve for cosine square. So cosine square theta equals 1 minus sine square of theta. Okay, so every time I see a cosine square, I can take it out and put this in there. So here we go. Let's rewrite our equation. Sine square of theta minus sine of theta equals, I'm going to take out cosine square and put this in. So that's going to be 1 minus sine square of theta. Then I'm just going to put everything on one side. So are you ready? So the next thing I'm going to do is add sine square to both sides. Okay. So those are now canceling. On the left side, I now have 2 sine square of theta minus sine of theta. On the right side, I still have 1. So the next task I'm going to do now is subtract 1 from both sides. So now I have 0 over here. On the left, 2 sine square of theta minus sine of theta equals -1. So now let's check this out. We are here, we're trying to solve for theta. Okay, very similar to this, don't you agree? Guess what you're going to do next? You can factor it out, okay, using u. And by the way, you don't have to use u, okay? Let u be sine of theta. So you can write 2u squared minus u. Oops, this should have been a -1. My bad. -1 equals 0. Okay, do me a favor and factor it out. I'll wait for your factors and I'll come back. Okay, take a minute. However you factor, factor. Once you have the factors, write it in. Don't forget to check your factors to make sure the factors are, when you multiply them back, they get the original. Did you come up with the factors? I hope you did. Okay. So did you end up with 2u plus 1 and u minus 1? Okay. If you doubt your factors, just quickly check it. Okay. 2u times u is 2u squared. 2u times negative 1 is negative 2u. In the middle is positive u and minus 1. When you add that, it should be equal to this. So we are okay. Then take each factor and set it equal to 0. So 2u plus 1 equal to 0. U minus 1 equal to 0. Then solve for u. Okay, so 2u equals negative 1. U equals negative 1 over 2. Similarly, u equals to 1. Okay, but obviously we're not trying to solve for u, we're trying to solve for theta. So put it back. U is, whoop, put it back, whoop. Okay, so we now have sine of theta equals negative 1/2, okay, or sine of theta equals 1. Sine is 1 is only at one location, okay, it's at pi over 2. So this one, I only have one answer. Now sine of negative 1/2, you're going to have two locations, here and here. So can you tell me the angles for those? Okay, did you say that it would be 5 pi over 6? I'm sorry, not 5, 7 pi over 6? Good. How about the other one? Did you say that is going to be 11 pi over 6? Great, okay. And that's all I needed, and let's just write it from smallest to biggest, okay. So theta is going to come out to be pi over 2. 7 pi over 6, and 11 pi over 6. Okay. Now think about this. 11 pi over 6 is already near 2 pi, so I don't have to worry about the period. So anytime that you have to factor, you don't have to worry about the period. Okay. Last problem. I'm going to use a different color just to separate my two questions here because it seems like I invaded F. Okay. This one, you can do this in a few different ways. Notice how you have sine square and cosine square in one equation. You can totally substitute, okay? Get rid of cosine square, just like what we did here. So here we go. 3 sine square of theta equals, every time I see cosine square of theta, I can replace it with 1 minus sine square of theta. And of course you can substitute sine square of theta as well, okay? So if you were to write sine square of theta, it should be 1 minus cosine square of theta. You can substitute whichever one you pick as long as it makes it easier for you to solve, not more difficult, okay? So from here, just like earlier, I'm going to combine like terms. So this is 4 sine square of theta equals 1. Divide both sides by 4. Sine square of theta equals 1/4. Take the square root. So now I have sine of theta equals plus or minus 1 over 2. Okay, what does this mean? This means that I have sine of theta equals positive 1/2 or sine of theta equals negative 1/2. Well, sine is positive here and here, so that's two answers. And cosine is sine is negative here and here. That's another 2 answer. So can you do me a favor and find all of those answers? What are all those angles? Did you say multiples of pi over 6? Then that is correct, okay? So we will have all of these answers together. So let's write them in. Theta is smallest to biggest. Pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. And that is my box answer. Now, is that the only way to go about this? No, not really. I can also go this route, right? Here's your original question. 3 sine squared equals cosine squared of theta. What if I don't feel like converting cosine into sine or sine to cosine? Then I can do this way. Divide both sides by sine squared of theta. Then I have 3 equals to cosine squared divided by sine squared is going to be cotangent square of theta. Okay. Then I'm going to take a square root. So now I have cotangent of theta equals plus or minus radical 3. Then again, because it's positive and negative, I again will have 4 answers, right? Cotangent is positive radical 3 in quad 1 and quad 3. And cotangent is negative in quad 2 and quad 4. And the angles are still the same. Pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. So it doesn't matter how you solve in mathematics. If you do it right, then the answer will always be the same. This is the end of our notes.